Hello, Stats class. Here's lesson 8.3b. We are continuing to talk about confidence intervals for a population mean. And I'm going to quickly review what we did yesterday with the t distribution, or in 8.3a. I guess it wasn't yesterday, but yeah. If you know sigma, which means the stats fairy shows up, very rare, then you use the formula x bar plus or minus z star times sigma over square root of n, and that is the population standard deviation. We talked about that in 8.3a a little bit. This is really unusual in real life, so we're not going to do very much of it. A little bit of it, but not much. In real life. Most of the time, we don't know sigma. That's the realistic version. And then we use the formula x bar plus or minus. Instead of z star, we use t star. And we use, instead of sigma, we use s, which is the sample standard deviation. And what that does, the sample standard deviation tends to give us more variation than we would like. And so we need a whole new distribution that is wider. The t distribution is still a symmetric and mound-shaped distribution. It looks a lot like a normal curve, except it's wider. And so the normal curve, if you just move this down a little bit and make it wider like this, then that's the t. So this is normal. This is t. The t has more in the tails than the normal curve, and that's the reason we need it. It's to make that capture rate of 95% actually be accurate, we have to go wider. It means our intervals will be wider than if we used z, but that's what we want to make it actually capture 95% of the time. And so to remember which is which, I invented Slim Z versus Tubby T to help you remember which one is wider. Because every once in a while on the AP test or on my quizzes, there might be a question about which one is wider. And yeah, you have to be able to remember that. You don't have to know much more about it because the rest is going to be done by the calculator. To find T star, you can either use table B, which is in the back of your book, but I also am putting a link to it on Canvas for you. Or you can use the inverse T if you have a TI-84, and you would need the area under the curve, and that's the area from that point down. That's the area I'm talking about, and then you need degrees of freedom. And for now, DF is always n minus 1, sample size minus 1. The reason why is complicated, and I'm not going to go there. And later it's going to change. So yeah, for now it's n minus 1, and then area under the curve is the C, or confidence level, plus half the extra, and we've talked about that lots. This can be found in second vars if you have a TI-84. If you don't have a TI-84, you probably don't have that on your calculator, and I'm a little disappointed because in class I give you the program that does this if you have an 83, and I can't do that this year, so it's really frustrating. We're just going to use the table or use the online version of it. So one more example of that just to make sure, and then I'm going to do a full 4-step confidence interval because we need that. So let's say we want to do 98% confidence just to be different. And let's say we have a sample size of 18. So we would do T star on the calculator, it's inverse T, and we would do 98 plus half of that extra 2% would give me a 0.99. And then I would, instead of 18, use 17. And that's what I would type on my calculator. Or I could look it up on table B, and I'll show you that one more time also. Remember, table B has the confidence levels at the bottom, so I find that easiest to look for the 98% down here instead of trying to deal with that top row. And then I'm going to look at the 17 row, and over to the column that has 98%, I got 2.567. Oh, and I just dropped some stuff, sorry. 2.567. And then I'm going to do it on the calculator also, just to make sure you have that example. If you're using a TI-84, you could do inverse T on the second vars menu and tell it to do 0.99 and 17. And any second now, there it is, 2.567. It's the same thing. That's wonderful. So 2 ways to get T star, and the third way is on the computer, which, like I said, I will show you during a Zoom class just to be sure. All right, so let's do a full 4-step test. I want you to see what the 4 steps look like with means instead of proportions. The thing that we are learning how to do, remember we're supposed to name our procedure, is called a one sample, this is the fancy name, and I'll probably abbreviate it later, the one sample T interval for a population mean. Or you could say for mu, and that would be fine. We're estimating mu with this interval. And I'm going to just do the 4 steps with an example and talk you through them as we go. So let's say we are working for a manufacturer of computer monitors. We're testing the tension of the screens, which is supposed to be a certain value. And if it's not, we're going to have to fix our manufacturing process. So we take a random sample of screens, and quality control means we test them to see if they are within specifications. And we're going to say 20 screens in our sample. And they're sometimes going to give you a whole list of data. On this one, I'll probably do that one next week on 8.3c. But for this one, I'm just going to give you X bar. The mean tension of our 20 screens that we've got is 306.32. The standard deviation of our 20 screens is 36.21. And we're going to do a estimate mu with 90% confidence. That's the problem. So like a normal AP problem, it doesn't really take a whole lot of information to give you what you need. It would normally give you a big blank space to write the 4 steps in, and I'm going to do all 4 steps. So here we go. Step 1, state. This is going to be a lot like what we did in 8.2. So I think I'm not going to write all the details. I'm going to kind of do the generic over here. We need to state our parameter in context. And we need to state our confidence level. And then I'm going to go ahead and write my sentence right here. I'm going to take this and make it better. So I'm going to say I'm going to estimate, what is it I'm estimating? I'm going to estimate mu, but what is mu? Mu is the mean, population mean of all the screens, not just the 20, right? So I'm going to estimate the true mean tension of the screens with 90% confidence. So I've got my context, I've got the word mean in there, not the word proportion, that's important. True implies population, or you could also say population mean, and I've got my confidence level. Plan. So now the plan, again, is not going to surprise you very much. It's the same stuff we were doing before. So we need to name our procedure and we need to do conditions. The name, the fancy book name is longer than I require. I would say the most important words here are interval and mean. You got to have those 2 words in there somewhere. So I'm going to say I'm going to do a confidence interval for a mean, and that is good enough for me. Or you could even say for mu. We will learn some other types later, and this one sample thing is a hint that later we're going to do 2 samples at a time, and we're using T, but you don't have to say that because I'm going to assume you're going to use T, right? The 3 conditions have not changed much. We're still going to have random and normal and independent, and you're going to get really good at checking all 3 of these. Random, did we get a random sample? Yes, it says so right there. So we're checking to make sure that's given. Yes, it's given. Hurrah. I'm not going to write any more than that. I'm just going to check for that word and do that. Normal. I have a little bit of a problem with normal. Do you see why? They gave me a sample size of 20, and I really would like it to be 30. So I'm going to say I am unsure whether this is normal or not because n is 20 and it's less than 30. And they didn't tell me the population shape. I would hope that the population shape would be normal. I'm going to go on anyway because I don't want you thinking you can just stop if a condition's not met. I'm going to say we hope the population distribution is normal because that would solve our problem. And some people like to write proceed with caution or something like that. So you can, if you want to, write that. It's kind of cute when kids write that, you know. But we're just going to keep going anyway, but we're going to say we're not quite sure if our calculations are accurate. Independent, we're checking 20 screens. It has to be less than 10% of all the computer screens that we're testing or that we're manufacturing. Oh yeah, that's definitely, I'm going to say yes to this. That 20 is most likely less than or equal to 10%. Remember, you can't just write N and N. You have to say the context. So of all computer screens to prove that you thought about that. So we've got two conditions met, and the third one, or the middle one, we're not sure about. But we're going to keep going anyway. 2, we're going to write out our formula. This is just the calculations. X bar plus or minus T star times S over square root of N. Almost the same formula we had before, just this part changed T and X instead of Z and P. So I'm going to plug in what I know. I'm going to plug in the X bar, which is 306.32. I'm going to come back to T star in just a minute because I'll need to either use the calculator or look it up. I can plug in S right now, 36.21 over square root of N, which is 20. So off to the side, I'm going to find T star, and I'll do it again both ways just to make sure. If I'm using inverse T, then I would need 90% plus half the extra, so half of that extra 10% would be 0.95. DF is 20 minus 1, which is 19. So this came from 20 minus 1. And I could type that in my calculator, inverse T, and put the 0.95 and the 19. And I'll show you on the table also, just in case that helps you. 1.729 is what goes here. If you're doing it with the table in the back of the book, you can look up 90% and find the row that is for 19, and there's the 1.729. So same T star you get either way. And then you can type this in your calculator, or it's probably a good time to tell you there is a calculator shortcut for this. And I believe this calculator shortcut is on the TI-83 as well as the 84. But let's talk about the calculator shortcut, since you know that there was one for the other one, right? You know there's got to be one for this. Stat tests. And let's have a look at that stat tests list and see if we can find this. So stat and then test, and then if we were in class, I'd be making you guess which one are we going to use. Definitely none of these ones that say test. We haven't learned those yet. But intervals. Oh, look, there's a T interval. That's a good sign. There's a 1 proportion, but I don't see a 1 sample. It's the T interval. It's number 8. And the Z interval is if you know what sigma is, which we don't. So the T interval is what we want. You have a choice of data. So like if you have a list of data in list 1, you can do that, which we don't this time. Or you can choose stats, and then it asks you for that same information you probably are expecting, which is the 306.32. And S is 36.21. And N is 20. And the confidence level is 0.90. So you just type in all the stuff that you know from the problem, or like I said, if you know the data, you can give it the data in a list. And you hit calculate. I still would like you to write this out to prove that you know what you're doing, but then if you don't want to type all that, if it's easier to type it on the calculator shortcut, you can. So stat tests, we chose t-interval, we put in all the information that we have, and it gives us our, kind of like magic, it gives us our interval, 292.32 and 320.32. All right, this is the answer to part 3, and I could get it from here, or I could get it from typing this. Last step, conclude, which is where you interpret the interval. So these things off to the side are the same instructions I gave you last time for proportions. So that's why I'm not putting details on those, because I feel like we've already done the details. We'll put it on the chart for sure, though, the details later on next week. So we are, how confident are we? We're 90% confident that here again, the book likes to put the interval first. And so they would say that the interval from this to this, I'll do it their way because it's probably good for you to see it that way, that the interval from 292.32 to 320.32 contains, what does it contain? We think it contains the true mean tension of the screens. So definitely use the word mean in there, not the word proportion. You could also say it the other direction if you wanted to. So you could say we are 90% confident that the true mean tension is between this number and this number. I don't remember what the units are on this, so I'm not going to try and do that. If you knew the units, you would put them. And remember that we're not saying that it's a probability. We're not saying that if we had this same interval again that it might not contain it because we know that the true mean doesn't move. If we did a different interval, then it might or might not capture it, and that's what we're talking about. We're 90% confident that this interval captured it, and if it didn't capture it, it's because the interval moved and not the real thing. So I'm going to stop there, and we will do one more example for sure on next Wednesday when we come back from the midwinter break, and that's in 8.3c. And then we have a quiz next week on 8.3. And really, I've taught you most of what you need to know about 8.3. There's one more detail that I'm going to put off until Wednesday and one more example.